Assalamu alaikum. In this video, we'll learn about the permutations. In order to understand permutations, let's have a look at this simple graphics to make the concept easier to understand. We have three letters, and we need to find out the possible arrangements that we can make from these three letters, where the sequence of letter is important. So it's very clear that at first place, we have three options. It could be A, B, or C, and we model this as a tree diagram. So here we have this first option taken, A. On the second place, if A has already been taken, on the second place, there are two options. It could be B or it could be C. And then at the third place, if B is already taken, only one option is left, which is C. In this case, if C is taken in the second place, then the only option left is B. And we do the same for the rest of these options. So here we get A, B, C, ACB, BAC, BCA, and so on. So these are the 8 different combinations that are possible when we are trying to find out how many different arrangements can be formed if we have 3 letters and we have to arrange them where the sequencing or order of the letter is important. ABC and ACB make a different pattern, and which means that it is one different item. These are known as permutations. A permutation is an arrangement of object in a definite order, as we have just seen. For if r items are taken at a time from n items, the total number of permutations are given by, this is how we represent the permutation, P, r choose n. So we have n total items and we are choosing r from them. The expression to calculate this, the number of permutations that we get is n factorial divided by n minus r factorial. In the example on the previous slide, we had 3 different items and we took all 3 of them to find the different permutations. So in that case, it would have been 3 factorial divided by 3 minus 3 factorial. By definition, the factorial value of 0 is 1. So essentially, it was 3 factorial. The other notations that can be used are P, N, and R this way. Let's consider an example. 6 students who top the class are to be photographed. The stage has space for 3 kids only. How many different arrangements of 3 are possible for the photographs? So here, we need to compute the permutations because changing the position of a student makes a different arrangement. So this is essentially a permutation. So we calculate the number of possible arrangements that can be made for the photograph. The total number of items that we have is 6, and we need to choose 3 from them. So we get 6 factorial divided by 6 minus 3 factorial, a total of 120 different ways that the students can be stood on the stage for the photograph. Consider another example. A group of 10 students appeared in a coding competition with 2 prizes. Before the results could be announced, one student fell sick and left. After a while, another student got called back by their coach. Now, what is the probability that these students got the first and second position, respectively, in the same order as the left? The first one who fell sick got first position, and the one who was called back got second position. Now, this question is asking to compute the probability of this event. And we are going to make use of the permutations for this. The total number of students we have here is 10, and we have only 2 positions for the prizes. So the number of unique arrangements with 2 students for the first and second position can be computed by the permutation formula, and we get 10 factorial, which is the total number of arrangement, divided by 10 minus 2 factorial, which is 90. So there are 90 different ways that those students can be picked for the first and second position. And only one of those 90 arrangements, is the one which represents this situation, in which the first student who fell sick got first position, and the second one who was called back by coach got the second position. So here, we compute the probability. Since each of these events, each of these arrangements is equally likely, the probability of each of one of them is 1 over 90. And this particular arrangement that we are interested in is, again, a single instance. So we get the probability of this event that exactly these 2 students were the ones who were the winners of this competition. the probability of this is 1 divided by 90, which is 0.01. Or in percentage, it is just 1.1% chance that these two students were the winner of the computation. Let's see another example. You remember using the numbers 4, 5, 7, and 8 as the PIN for your bank card, but you do not remember the exact pattern. Now, how many different patterns are possible with these numbers? The order is important here because, of course, 4, 7, 8 is a different thing, a different pattern, and 4, 5, 8, and 7, just altering the position of the one of these digits makes a totally different pattern. So we compute the permutation, and here we have 4 items, and we're choosing all 4 of them. So we get the total number by this expression, which is 4 factorial. Because even if we use the entire expression, we will have 4 factorial divided by 4 minus 4 factorial, which is 0. And we know that by definition, the factorial value for 0 is 1. So we have a total of 24 different patterns which are available with these 4 digits. Now, here's another example. If you have 10 different colors on a palette, how many different 3-colored gradient patterns can be made without mixing the color? So by gradient, we mean that one color changes to the second and then to the third. So we arrange those colors in some order. So here, a color changing its position is going to make a totally different pattern. So we are going to apply the formula for the permutation calculation. The total number of colors available is 10, and we're choosing 3 at a time. And this gives us a total number of 70 different gradients possible with 3 colors being chosen from the palette.